In this tutorial, we're going to look at the software development lifecycle. If you have a look at Systems Analysis and Design with UML by Tegarden et al., it's defined as the process of understanding how an information system can support business needs by designing a system, building it, and delivering it to users. However, that's quite a mouthful. If you distill this down to really what the essence of the software development lifecycle is, we can come up with the idea that it's a formalized process for developing software. So you can still be thinking about the designing, building, and delivering stages within that developing software part, but the key thing is that it's a formalized process, so it has stages that you end up moving through. Now, why formalize the process at all? The key for this is always going to come down to attempting to minimize risk of project failure, or on the other hand, increasing the likelihood for project success. Now we're going to have a look at the stages of the process, and there's four. So we start from planning and we move through analysis, design, and implementation. So the sort of thing that's dealt with in each of these individual stages, if we look at planning, planning is all about why we should build the information system. So you're going to be looking at the business, you're going to look at the business context and the reason or value for building the information system. So what return is the information system going to give? In terms of sort of how we're going to go about building it, these sort of questions, or the questions that the business to be asking are, are you going to be developing this in-house? Are you going to develop out-of-house by contracting? Are you going to be buying an off-the-shelf system or something that can be modified? And those are the sort of questions that are going to be answered in that how we're going to go about the building of the system. Analysis. Analysis is all about the users. So who is going to use the system, what are their user needs, requirements, and also what will the system do. So this is about scope. One of the main reasons for project failure is scope creep, or loosely defined scope, where the project requirements are changing and changing and changing, or more and more things are being thrown in, and it just sort of balloons in terms of the amount of work that needs to be done. Once plan analysis is done, we move on to the design stage. So the design stage is all about how the system's going to operate. You're going to be looking at hardware, software, network infrastructure, these sort of considerations. So first of all, the sort of questions that you're going to be solving here in the design phase are, what operating systems you're going to be using to host the system, what languages you're going to use to implement the system, what database systems, where they're going to be stored. Are you going to be running them locally on your own servers? Are you going to be hosting them in the cloud? Can you scale them up by utilizing cloud infrastructure? Can you operate continual deployment? All these sort of questions are going to be answered in sort of how the system's going to run or operate. Once you've finalized or finished all the design, you move into the implementation stage, which is probably the longest section. So this is all about where you build, actually put together, or purchase in the system itself, and it's made up of three main phases. You've got construction, the actual production of code, installation, or deployment. So for instance, if you're building a web app, this is actually pushing it out to your live servers, so it's ready to go live. If it's being run locally on user workstations, it's about installing that software on those workstations. And also the support plan. So don't forget, it's all about getting the users actually using the system. So if you've come up in the analysis for user needs of training, then this is where the training actually gets rolled out, or taken place. So the users are taught how to use the system, it's set up, it's running, and it's in use. So ideally, by the end of the entire information system, the information system, for whatever purpose it was built for, it's met that needs, it's met the needs of the users, the scope's been right, and it works. It does what it was supposed to do, and solves a real world problem. Now each of these stages have deliverables. So the planning phase will generally produce the feasibility analysis and the project plan. So the feasibility analysis is all about, can we build the system? Do we have the technology to do this? Do we have the expertise to do this? Will it come in at a reasonable cost? These are all things that are in the feasibility analysis. The project plan is all about how the project's going to be built. So some sort of project manager will be producing that initial project plan. Then we've got the analysis phase, and the deliverables from the analysis phase is the system proposal, which is made up of all the analyses. Because when you're looking into sort of the users of the system, you're going to be conducting interviews, maybe questionnaires. You've got to be gathering data. So analysing all the data that's been gathered, the concept for the system, and the models that get produced. So, for instance, use case diagrams, or whatever else that you're doing to sort of model and look at how the system is going to be used and what it's going to do. For the design, the deliverables, or things produced, generally are sort of the system specification, and this consists of the architecture design. So again, literally is sort of hardware and the interface, the software itself, how it's laid together, perhaps even what design methodology is going to be using, or design patterns, the interface designs, database and file specifications, and all the program design itself. So this covers everything, sort of UI or UX design, all the planning documents. Basically, the perfect design should mean that if you took your design and you gave it to 10 different sets of developers, you pretty much get the same back. And I'm not saying it's necessarily actually going to work like that in the real world, but the question to be asking yourself is this comprehensive? Then finally, moving on to implementation, the key deliverable is the working system. That's the end goal for everything. So is it in place? Is it working? Are the users using it, etc.? Did it meet its requirements? Okay, so those are the stages of the SDLC. Remember, it's not a methodology. It is a formalized process. So it's the stages of the process that you go through to build software. We are going to look at methodologies. So if I flip over, here are some examples of some SDLC methodologies. So we've got Waterfall V-Model, which I've put under Waterfall because it's kind of like an extension to Waterfall. You've got Parallel, Rapid Application Development, or RAD, Phase Development, Prototyping and Throwaway Prototyping, Spiral, Agile, which I put Extreme Programming and Scrum under that because they're all different forms of Agile development. There are a lot of different methodologies, and a methodology is an implementation of the SDLC process. So how do you go about moving through these phases would be a methodology. The key things to look at, or two main things to look at in maybe a future video, are Waterfall, which is like the basis, old school way of developing, and Agile, which is a more modern practice that appears to produce better software.